Hello. This presentation is to show the equivalence of the discrete and probabilistic forms of measuring mean and variance. For further description, we'll move to the next slide. So the discrete functions used to calculate mean and variance and standard deviation, you'll know from your statistics class, which is taking the various observations. Those are the xi's for the observations, adding them together and dividing by the number of observations. That would be n. That gives us the mean, which is the x bar. Now the variance is takes the observation, subtracting the mean that we just calculated, and squaring those, adding them all up, and then dividing by n. That would be for the population variance. Now looking forward and using probabilistic values, the expressions look as follows. Instead of having an x bar for the mean, we have an e of x, which is the expected value, but it's basically the conceptual equivalent. So the expected value is calculated by taking the individual probabilities times the values of for those probabilities from 1 to n being the total number of possible outcomes. The standard, or rather the variance, would be taking again the observations, or rather the potential values, then subtracting the expected value and squaring it, multiplying it now by the probability, and then that's also going for all of the various options from 1 to n. I'll show you, use some numbers and demonstrate what it looks like. So let's pretend we're looking for the expected value or the expected return on a share, where 40% of the time we'll say would have a chance of getting 5% return, 30% chance of a 10% return, and a 30% chance of a 15% return. You'll notice the probabilities, of course, here have to add up to 1. In other words, that covers all of the possibilities. And as you can see, it's a model because in real life, the values could and probably would be something besides those 3 discrete values. So if you look at it, we can consider calculating it using the expected value calculation and the standard deviation, or rather the variance calculation that I just showed. But we can also translate these into hypothetical returns. Let's take 10 observations, and 4 of them would be 5%. 3 of them would be 10%, and 3 of them would be 15%. Looking at that, you can see that the probability of a 5% return would have been post facto 4 out of 10. And for the 10% and 15% returns, you'd have a 3 out of 10 probability. So you can see that calculating the mean of these observations and these returns would be similar to calculating the expected value of these probabilistic returns. And the same would go, of course, for the variance and the standard. So calculating the mean, we would have 4 observations of 5%, 3 observations of 10%, and 3 observations of 15%. Dividing by 10 observations, we would end up just rearranging that equation, and you can see by taking the fractions 4/10, 3/10, and 3/10 times the values of those observations, 5, 10, and 15%. Calculating that out, we would come up with a mean of 9.5%. As you can see, the 4/10, 3/10, and 3/10 here are basically the expected, the probabilities of each of those values, 5, 10, and 15, in the table on the top table of the previous slide. So you can see that our result is exactly this form, which is expected value is just the probability, those 3 probabilities times the values of those probabilities. So now we can look at the variance and the standard deviation and compare those as well. Now the variance, using the observations, in other words, the historical values, we'd have 4 observations of 5%, so the standard deviation, or rather the variance, we would calculate by taking 5 minus the mean value, the 9.5%, and squaring it. We would have 3 times, we would have the observation of 10%, so we would do it there, and 3 times we would have the observation of 15%, or the values. So then again, dividing by the number, which is 10, we can rearrange this as 4/10 of the first run of 5 minus 9%, 9.5%, 3/10 for the second values, and 3/10 for the third values of 10 and 15% respectively. As you can see again, we've come up with probabilities of the 4 out of 10 probability, the 3 out of 10 probability, and the 3 out of 10 probability. So once again, the answer here would be exactly the same as in this form where we have the variance is equal 1 to n being 3 in this case, of the probability of a given value times the value itself. This would be, for example, the 5, 10, or 15% minus the expected value, which is the 9.5% squared. So there you have it. You can see how the two versions are similar. The observations that we've looked at in statistics are using the actual values, dividing by n, and squaring with the variance. And here we're looking using probabilities, looking forward. We take the probabilities and they represent how the frequency that we would expect to see a certain observation. And you'll see that it comes out with the same answer. Hopefully that helped, and thank you for listening.